For the function f of x equals negative 2x squared plus 4x minus 5, we're asked to analyze the function and graph the parabola for that function. We see the function is in the standard form, ax squared plus bx plus c. Let's determine whether the parabola opens upward or downward. My a parameter is negative 2, which is less than 0, so the parabola will open down. Finding the axis of symmetry. Since it's in that standard form, then the axis of symmetry is provided by x equals negative b over 2a. So therefore x is equal to negative, the b parameter is 4, over 2 times the a parameter is negative 2. Two negatives, that gives me a positive. Then we'd have 4 over 4 is 1. So therefore, the axis of symmetry is that x equals 1. Finding the vertex. We know the x-coordinate of the vertex is 1 because it's on the axis of symmetry. So the x-coordinate of the vertex is 1. The y-coordinate of the vertex is the function's value at 1, which is negative 2 times 1 squared plus 4 times 1 minus 5. Following the order of operations, this would give us negative 2 plus 4 minus 5. And going through this addition and subtraction is negative 3. So the vertex is the point 1, negative 3. Let's find the y-intercept. F of 0 is negative 2 by 0 squared plus 4 times 0 minus 5. That's 0 plus 0 minus 5. F of 0 is negative 5. The y-intercept is 0, negative 5. And the point symmetric to the y-intercept. Well, let's go ahead and start sketching. Let's put some scale on the axes. I see that the axis of symmetry is at x equals 1, and I see that the y-intercept is at negative 5. So let's use a scale of 1s on each axis. 1, 2, 3. There's 5 on the x-axis. 1, 2, 3, 4. There's 5 on the y-axis. 1, 2, 3, 4. Negative 5 on the y-axis. Alright, so what do we have? We have the vertex at 1, negative 3. We have the y-intercept at 0, negative 5. And we're asked for the point, the symmetric point to the y-intercept across the axis of symmetry. Well, the axis of symmetry is here at x equals 1. And so then the point symmetric going 1 unit on the other side of the axis of symmetry is the point, let's see, that point would be 2, negative 5. Now let's think about this. We have a parabola opening down, and the vertex is below the x-axis. We're asked to find the x-intercepts. There are none. We can see that from the work we've done so far. Let's verify it. Let's make sure that we haven't made any other mistakes. Let's verify it by applying the quadratic formula and to find the x-intercepts. So solving negative 2x squared plus 4x minus 5 is equal to 0, and applying the quadratic formula, then x would equal the opposite of 4, plus or minus the square root of 4 squared minus 4 by negative 2 by negative 5 over 2 times negative 2. Simplifying, this gives me that x is equal to negative 4 plus or minus the square root, 4 squared is 16, minus 4 times negative 2 times negative 5. Well, that's going to be a minus, right? 3 negatives, so minus. 4 times 2 is 8, times 5 is 40, over negative 4. So then x is equal to negative 4 plus or minus the square root of negative 24 over negative 4. And right now we can say, well, wait a second, that square root of negative 24, that's non-real, right? That's not real. And what that tells me, once I see that, is there are no x-intercepts. There are no real zeros. There are no real solutions. So therefore, there are no x-intercepts. And so that verifies what we had already learned from the previous steps in graphing this function. And so then going back to the graph, I know the parabola is opening down, and I have the vertex, and I have a couple of points on the curve. All right, so let's go ahead and draw a rough sketch of the parabola, trying to hit those points. This is poorly done. All right, so there's half the curve, and there's another half of the curve. So there's the graph of the function f of x equals negative 2x squared plus 4x minus 5.